I think it's pretty clear at this point that AI agents are remarkably good at writing code. I mean, most engineers have seen examples where you can describe a problem in plain language, ask an agent to generate a solution, and then watch it produce functions and tests and documentation and applications. And this naturally leads to a much bigger question. If these systems are so good at writing code, can they actually help us engineer complex systems? And I cover part of that question in my previous video on agentic AI and model-based design, and in that video, I explain how engineers can guide an AI agent throughout the development process, bringing their own expertise, judgment, and experience into the loop. But this real-time feedback isn't the only way to provide engineering expertise to an agent. Another way that we can do this is with skill files. And these allow us to package engineering knowledge, best practices, workflows, and guidance into a form that an AI agent can reuse over and over again. So, let's get into how they work. I'm Brian, and welcome to a MATLAB Tech Talk. Now, to begin, I want to start with why AI agents are so good at coding, but not necessarily that great at engineering. And the answer is actually pretty straightforward. Modern AI models have been trained on enormous amounts of publicly available information, and code happens to be one of the things that the internet has lots of. And so, as a result, when you ask an AI model to generate code, there's a decent chance it's seen many examples that look similar to the problem you're asking it to solve. But engineering knowledge is different. The most valuable engineering knowledge usually doesn't live on the public internet. These are things like the workflows used to develop safety-critical systems, the lessons learned from previous projects, the internal standards that keep a large engineering organization consistent, and the design trade-offs that experienced engineers have learned over years of practice. And while you could provide all of that context in the form of a prompt every single time you start a conversation, that quickly becomes tedious. You'd end up with rewriting the same instructions over and over again. And so this is where skills come in. A skill file allows that expertise to be packaged into a form that an agent can load and apply when it encounters a particular type of task. Instead of approaching every problem with only its generic training, the agent can augment that knowledge with additional engineering guidance supplied by the people who actually understand the domain. So let's walk through a quick demonstration of what I'm talking about with a system identification example. Here, I have this input data that I played through a system with unknown dynamics, and then I measured this noisy output signal. And now I want to identify a linear model that best represents the dynamics of this system. And to help me do this, I'm going to use an AI agent, which is OpenAI's Codex in this particular case, that's running the GPT 5.4 model. And I've given Codex access to MATLAB through an MCP server. And this just means that Codex can interact with a live instance of MATLAB, which will maintain state and it has a standard interface, both of which makes the process more efficient. All right, so let's try this prompt. I want to build a MATLAB script that can identify a linear dynamic model from the input and output data that is stored in a data.mat file, and then plot the results. The variables in the file include time, t, input u, and output y. And now it's off and running. And I'm certainly not going to cover everything it's churning through here because, it's a lot. But the basic idea is that it opened up MATLAB, and now it's checking to see which toolboxes are available. And it figured out that I have the system identification toolbox and that it should use the functions from that toolbox instead of writing its own. Then it's building the script, and it's correcting any runtime issues. And this is what it came up with. It generated several figures. In the first, it plots the input and output signal that I gave it. And then in the second one, it shows the difference between the measured output, which is the noisy gray line, and the identified model output, which is the smoother blue line. And you can see that they match pretty well. But, I know it's a little hard to see with this default font size on the figures here, but the fit between the two is about 90%. And then in the third figure, it took it upon itself to plot the model residuals, which is the difference between the model and the data when looking one step into the future. And we would expect a model that captures the primary dynamics of the system to have residuals that look like white noise. So it did this on its own, which I think is kind of a nice touch. And that's pretty cool, right? From a coding perspective, it did exactly what I asked for, and it even did a little bit more. And this is what I'm talking about, that these coding agents are really good. However, even though this is what I asked for, it's not quite what I wanted in terms of following best engineering practices. For one, it used all of the data to fit a model, and then it returned the fit percentage for the whole thing. And this might lead to a model that overfits the estimation data. I'd much rather it split the data into an estimation set and a validation set, so that the fit percentage is against data that it hadn't seen yet. I'd also like it to show me the stability of the final model, and importantly, I don't want it making decisions without me understanding what it did, so I'd really like to have a summary of its recommended selected model and why. Now, I could certainly prompt the agent to do all of this, but again, I'd always have to bring this up every single time I want my agent to do a system identification task. So instead of that, I'm going to have it create a skill file with my engineering best practices. And first off, let me delete the script that it already created so that we're starting from absolute scratch here. And now I'm going to go back to my agent and I'm going to tell it to create a skill file that is called whenever it's performing system identification. So I want it to split the data into estimation and validation sets. Also, I want it to check residual whiteness. It was already doing that, but I don't want it to forget that step. And then I want it to generate validation plots showing the input data split and the residuals, plus the stability of the model and the fit against just the validation set. And I also want it to produce a summary recommending the selected model and why. Skill files, by the way, are just text-based markdown files that you can read and edit as necessary. So once you have a draft of a skill file, you can just go in and add to it or modify as you see fit. Let me just open up the skill file that it created real quick so that you can see what it looks like. And this is stored in a skills folder along with any other skills that you've created. And like I said, I can make changes to this directly, or I can add to it as I come up with new things that I want my agent to adhere to. So now, when an agent evaluates a new prompt, it's going to look at the descriptions of the various skill files that it has access to, and if it determines one or more of the files are relevant to what was asked of it, then it will read the content of those relevant skill files and treat it similarly to a user prompt. So, with this skill in place, I now want to start a new session. And I'll start by just closing MATLAB, and I'm going to close the terminal running codecs. Now I'm going to open up a brand new session and then prompt the agent to build a system identification MATLAB script. In fact, I'm using the exact same prompt as before, except this time you can see that it's calling the system identification skill because the agent determined that I asked a system identification problem. And now, once again, it's going to churn through a bunch of stuff like it did before. It's opening up MATLAB, it's using the system identification toolbox, and it's writing a new linear system identification script. And then when it runs, the script generates several figures. The first figure shows that the agent actually split the data up into an estimation set, which it uses to estimate the model, and a validation set that it uses to test how well the model performs on data that it hasn't seen. The second figure shows how only the validation set performs against the raw data. And again, it's about 90% fit like we had before, so it's probably a very similar model, but at least now it created it in a way that I controlled. The third figure shows the residue correlation, and then the fourth shows the residual versus time. And finally, the fifth shows the stability of the model by looking at the pole zero map. And it's a little hard to see the poles and zeros on this, but we can tell that the model is stable by ensuring that all 4 poles exist in the left half of this graph. Oh, and by the way, I could add a new skill file that formats figures and graphs in such a way that everything is easy to read in a video like this, but I didn't do that here, which is why the font size and the marker size on my graphs are hard to see. But anyway, lastly, the agent also generated a report like I asked for, and it's telling me that it chose a 4th order transfer function because it's stable, it passes the residual whiteness verification, and it delivers the best validation fit. And I didn't have to ask for any of this in my prompt. It was all baked into the skill file. And so every time in the future that I ask for a system identification problem, my agent now knows how to do it. So hopefully you can see that there's value in creating skill files to give your coding agent more context around how to do engineering. And for MATLAB and Simulink users, that's one of the benefits of the Agentic toolkits that we've developed. MATLAB Agentic Toolkit and Simulink Agentic Toolkit give AI agents access to MATLAB and Simulink through an MCP interface, like I was using in my example. But in addition to that connectivity, the toolkits also provide skill files that package engineering guidance and MATLAB and Simulink knowledge into a form that agents can use directly. And then by creating additional skill files, you can layer your own specific expertise or company standards on top of that foundation, creating agents that better reflect how your organization approaches engineering problems. So that's where I'm going to leave this discussion for now. I hope this has given you some inspiration for how you can get AI agents to assist you in your engineering development. And if you want more information on skill files or on the MATLAB and Simulink Agentic toolkits, I've left links in the description below. And if you enjoyed this explanation, you can find all of the Tech Talk videos across many different topics, nicely organized at mathworks.com. Thanks for watching, and I'll see you next time.